Yes, good morning everyone. So our topic is unit 2 topic is pulse modulation. Yes, everyone do the response in what are the main process we are performing in analog to digital conversion. Yes, sampling and quantization. Okay. So can anyone say the what is sampling theorem? What is the expression for sampling theorem? Everyone do the response in the chat box. Sampling theorem expression in terms of Fs. Fs. Abhishek, you can share the content bar. Fs, not Fc. It means sampling frequency should be greater than or equal to 2 into Fm. So can anyone say what is it equal to 2 Fm means what it is? Greater than or equal to or at least equal to 2 into Fm. Yes, this is the general expression for sampling theorem. Good, Gary. So what are the three categories in sampling theorem which we have drawn the diagram? List out the categories. Fs is equal to 2Fm. Everyone do the chat box response. Fs is equal to 2Fm. Then Fs is greater than 2Fm and Fs is less than 2Fm. Okay. So what it refers, Fs is equal to 2Fm. Yes, can anyone unmute? What is the purpose of sampling theorem? Why we need to go for sampling theorem? What is the purpose?
Sir, converting the analog into digital, sir.
Converting the analog into digital. It means the continuous signals will get discretized.
Yes, sir.
Right?
Yes,
Okay,
sir.
if we are not applying sampling theorem on our wireless communication channels, okay, so what is the reflection? What will be the reflection? Or what kind of issues we will have?
Sir, overlapping.
Directly I can ask what is the, how to overcome or what is the issue we will have, then how to overcome. What is the issue? It starts with A. Or in general, we can say it starts with O.
Sir,
When we are
overlapping.
not, huh? What is it?
Overlapping.
Overlapping, yes. When we are not having, it depends on frequency and bandwidth allocation. Okay. So whatever the required bandwidth, if we haven't allocated, so what happen? Obviously, our channel, first channel will get easily overlap with the second channels. So if both first signal as well as second signal is closely towards or closely equal to the signal, it means whether Fs is equal to 2Fm or less than 2Fm or greater than 2Fm. When both the signals are closer,
Sir,
not
equal to
overlapping, when both the signals are closer towards mean Fs is equal to 2Fm. It mean whatever required I have allocated exactly. Not increased data bandwidth I have allocated, not the reduced data bandwidth I have allocated. Whatever the requirement I have allocated. Okay. Yes. So what is less than 2Fm? What is the condition for less than 2Fm? What will happen? When the
Sir,
sampling frequency is less than 2Fm.
the distance அதிகமா இருக்கும் sir.
Less than. Try to understand. I am allocating less than what I require. What happened? My signals or my frequency signals getting overlapping with each other. That is the process called aliasing. Correct? So the other name for overlapping is aliasing effect. So how to overcome the aliasing effect or overcome the overlapping? What we supposed to do? We need to apply twice than that of, greater than twice than that of required. Fs is greater than 2Fm. If I have allocated, there won't be having any overlapping because there will be having band gap between two signals. Yes, have you seen those diagrams? When we have band gap between two signals, there is a possibilities of overlapping is very less. So the overall channel will work effectively without any error. Noise will get reduced. The overlapping have been reduced, mean aliasing effect also reduced. Then my signals, proper signals will travel within the allocated channel. It means we won't have any data loss in the networking signals or mobile communication signals or satellite communication signals or any communication signals. Okay, this is the common factor. Okay, sampling process, sampling is done. Then we have derived the sampling theorem. Okay, transmitter part and then reconstructed part. Okay, sampling theorem is most important 13 mark question. Okay, second one, quantization. What are the two processes in quantization? Upper round off and the lower round off. Okay, it means what we need to do, we need to approximate the integer values, right? 1.587 will be approximate into 1 or upper cutoff into 2. Okay, then followed by different modulation techniques like PCM, DPCM, and the delta modulation. Okay, adaptive delta modulation, then differential pulse code modulation, adaptive differential pulse code modulation. These are all the modulation techniques we have learned in unit 2, pulse modulation techniques. Okay, okay, then followed by, so what are the two topics in channel vocoders? What are the two topics in channel vocoders? It is based on the multiplexing. Hello, guys, do the response in the chat box. What are the two topics, two main topics in channel vocoders? Guys, is it audible? Jayashree, you can come to online. Jayashree, Harini, what are the two topics in channel vocoders? Guys, others you can do in chat box. Do the response. Hello, is it audible?
Yes, sir.
Abhishek, anyone?
Yes, sir. Audible, sir.
Then why there is no response from your side? Kartikeyan, yes. Maunika,
சார் கொஞ்சம்
Karthike,
டாபிக்ஸ் ரிலீஸ் பண்ணல சார், அதனால தான் கொஞ்சம் கன்ஃபியூஷன் இருக்கு சார்.
yes, you can tell the confusions now. I can clarify you.
சார் இன்னைக்கு தான் பார்க்கணும் சார் ஈவினிங். ஆக்சுவலா
I'm just asking the topics which we have come across. That's it.
சார் சாம்பிளிங்.
Sampling, quantization. Okay. Those are the two main process. Then we have learned the theorem in sampling theorem. Then quantization process also we have understood. Then followed by quantization noise. Okay, how to eliminate the noise, aliasing effect. Okay. Then followed by pulse modulation techniques. So what are the topics we have learned in pulse modulation techniques? Three
PCM.
types. First one, PAM, PPM,
PAM, PPM, PCM.
pulse amplitude modulation, pulse position modulation, and pulse width modulation. Pulse width modulation. This is the basic digital pulse based modulation techniques. Then code based PCM, pulse code modulation. Then subcategory of PCM, DPCM, differential pulse code modulation. Then one more subcategory, adaptive differential pulse code modulation. Okay, these three topics are individual 8 mark or 13 mark questions. Okay, PCM, DPCM, adaptive, differential, pulse code modulation techniques. Okay, this is one category. Then followed by delta modulation. So what are the subtopics in delta modulation? Why we need to go for a delta modulation? In pulse code modulation, we are using 1-bit quantizer, okay, but it takes more bandwidth. So to overcome that noise which is available in the pulse code bandwidth, we are going for a delta modulation. Delta modulation also having some noises. So what are the two noises? Staircase noise and what is one more? Staircase noise, and then one more, granular noise. Okay, so in order to overcome these two noise, what we have to do, we need to allocate, or we need to uh, dedicate the bandwidth into 1-bit quantizer into 2-bit quantizer. Okay, then delta modulation also we have a transmitter diagram and receiver diagram. Then followed by adaptive delta modulation, we have one more diagram in the transmitter of delta modulation. One logic diagram will have. Okay, in receiver side also we will have the same thing. Okay, so almost ADM, delta modulation, ADM. Okay, then any other topic we have left out, guys? PCM, DPCM, ADPCM. Fourth topic delta modulation. Fifth topic adaptive delta modulation. Each one, okay, is 13 mark. We need to draw the diagram, transmitter diagram, and then receiver diagram with the expected mathematical expression. Okay, very simple theoretical topic. Okay, just comparison diagram. Just do the comparison of each diagram. So you can easily understood what is conveyed in the. We won't have a much difference with each topic. There's slight variation in one topic with another. That also we have seen. Okay. Then followed by what is the last part in unit 2? The musical instruments we are using. It means we have a lot more number of inputs. At last, all those input have been converted into one component. What is the concept name? Multiplexing. Okay. So which is categorized into two categories. One thing is based on time based. What is one more? One multiplexing is based on time. What is the second multiplexing? Is based on, yes, anyone? TDM. What is one more topic?
Frequency, sir.
Frequency, yes. Okay, TDM and FDM. Those two topics is a real-time example which we are performing in the
Coding and
musical
coding.
and then audio instruments. How we are converting or how we are combining different audio inputs, different instrument audio as well as vocal audios into one, at last combined into one single audio output like MP3, MP4 like this. Okay.
Yes, sir.
So this is the brief of unit 2. Okay. So what is our third unit? Digital modulation techniques. So there we have learned PCM, pulse based. Okay. Pulse amplitude, pulse width. Okay. PAM, PPM, and then PWM, then PCM. Pulse based. Everything is depends on pulse based in unit 2. Here, in the third unit, digital modulation techniques is based on the keying method. Okay. Make a note of it. All the title have been ends with keying. Okay. It means BPSK refers binary. Guys, take note down. Most important 3 topics in this. BPSK, binary phase shift keying. Okay. Binary. First one, binary phase shift keying. Second one, binary frequency shift keying. Third one, quadrature phase shift keying. BPSK, QPSK, and BFSK. Okay. Okay. So what is a transmitter diagram? First one, BPSK. Guys, you need to explain this. BPSK refers, what is the left hand side parameter? What is the first parameter we are saying? Transmitter part. So transmitter part, what is the two input we require? In transmitter part, what are the two essential inputs we require to modulate that we have learned from unit 1?
Signal, sir.
Yes.
Magnetic signal.
In order to modulate or in order to transmit, I need a basic of two signals. What are they? First one?
Sir, analog signal.
Yes, analog signal. What is it? In generally, how we can say? In generally, it is a message signal.
Carrier.
To modulate, what are the two signals I require?
Modulating or message signal, sir.
Modulating the message signal is in terms of lower frequency. What is the one more?
Carrier.
Modulated with high frequency signal is a carrier. Guys,
Yes,
now you need to look at the diagram of coherent BPSK, binary phase shift keying. So what we have performed? So what is the left hand side? Binary wave is in polar form.
Yes, sir.
We already represent. See, guys, in second unit we have left one more topic. We have forgot to discuss what is one more thing. Line coding, right? Guys, can you remember line coding concept? Line coding. So what are the subtopics in line coding? Polar format, bipolar format. Okay, then any other? NRZ, what is NRZ? NRZ polar, NRZ bipolar, and RZ. What is NRZ? Non-return to?
Non-return zero, sir.
Non-return to zero, polar, non-return to zero, bipolar, and RZ. Return to zero, polar, return to zero, bipolar, then followed by any other subtopics? Any other format of line coding? Manchester coding.
Oh, yes, sir.
Okay, Manchester coding. These are all the line coding methods. So that's what they have mentioned in the input side. What they have mentioned, binary wave. What is it? They have mentioned in the form. What type of form? Guys, could you able to view the diagram? You
Yes,
can
sir.
zoom the diagrams. Coherent BPSK. What is our input? Binary wave in polar form. That is our message signal. What is I1 of t? Is our what is the component? What is the component? Cos 2 pi FCT. So what is FC?
Frequency, sir.
Sir,
Frequency of carrier.
FC. What is FC refers?
Frequency, sir.
Yes, frequency.
Carrier
FC refers
frequency.
Carrier frequency,
carrier
sir.
frequency. Okay. So binary wave in polar form is our message signal. Is getting modulated with psi 1 root of 2 pi TB into cos of 2 pi FCT of a carrier signal is getting modulated. So what is the output we are getting? What is the output we are getting? Binary. What is our title?
Binary phase shift keying, sir.
Amplitude, phase, and binary phase shift keying as a wave. Okay, you can go to the
Yes,
next
sir.
diagram. Next transmitter. By coherent. Previous diagram is the transmitter diagram of coherent phase. Here
Frequency.
frequency. Okay. So there we have only one modulator here.
Inverter, sir.
Here we have two modulators. Okay. M1 of t, M1 of t, adoda inverter the second la. Correct.
Yes, sir.
So the upper hand side is positive one, second the lower one is negative one. Here also what we have, our input is binary wave on off signal form. Okay. It means if in case switch on the pulse will have an one peak. If in case off there won't be having any amplitude. Correct. So that is our message signal. That message signal have been given to the positive half side and then negative half side. So what is F1 and F2? Guys, psi 1 of t and psi 2 of t, what it is? Message signal கொடுத்தாச்சு. So what is the next part? If we want to modulate, what we have to do, what we need of higher frequency? What is F1 of t and F2 of t? F1 of t is a carrier frequency signal 1. F2 of t is a carrier frequency number 2. Okay. In previous diagram, we have only one carrier. Here we have coherent binary frequency shift keying. We have one message signal and then two carrier signal F1 and F2 of t. Both have been modulated. So what is the output? Both have been sum in added. So what is the output we are getting? Binary frequency shift keying wave. Okay. Okay, you can go to the next diagram. Next transmitter diagram. So we have completed the diagram for BPSK and BPSK transmitter diagram. So what is the next one? Binary
coherent
binary
phase shift keying.
QPSK, quadrature phase shift keying. Q refers quadrature. Make a note of it. Coherent binary quadrature phase shift keying. Okay. Now you have to say what is the difference in these two. It means BPSK and QPSK. What is the difference? Binary input.
Sir, inverter is not, sir.
Inverter process. Okay. It means what is the input for QPSK?
Demultiplexer.
Binary wave, where we have got the binary wave.
Demultiplexer, sir.
Go to the first transmitter. What is the input here? Input binary wave. So where we are getting binary wave, input binary wave. BPSK is output. Let's go to the next one. Next diagram. Yes. Binary FSK. This is the input for QPSK. Have you understand? QPSK for binary quadrature phase shift keying. BPSK is our input. Okay.
Okay, sir.
Okay. Here the carrier wave is here the input have been divided into B1 of t and B2 of t. Then carrier we have only one carrier. Square root of psi 1 of t, square root of 2 by t into cos 2 pi FCT. FC we already know carrier frequency. So when both have been combined, in B2 of t as a carrier number 2.
Yes, sir.
Okay. Psi 1 of t is a carrier number 1. Psi 2 of t is a carrier number 2. It both have been combined, both have been modulated and have been combined using summer. At last we will get QPSK. It means quadrature phase shift keying. Okay. This is the transmitter diagram for QPSK. Okay, you can go to the next diagram. Differential
PSK.
phase shift keying. Okay. Differential refers, the name itself refers, we already know. Some part of signal have been given back to an input.
Yes, sir.
ஞாபகம் இருக்கா? PCM ல பார்த்திருக்கோமா? DPCM ல differential pulse code modulation ல பார்த்திருப்போம். கரெக்டா? A part of signal have been given back to the input. There we have used delay. கரெக்டா? டிலேனாலே நாம அங்க என்ன யூஸ் பண்ணோம்? n-1ன்ற கான்செப்ட் யூஸ் பண்ணோம். ஞாபகம் இருக்கா? Delay refers, delay number 1 refers n-1, delay number 2 refers n-2. As like here also our input sequence is input binary sequence, logic network, and delay 1 bit have been delayed to a -1. Amplitude shift level shifterல நாம அதை இன்புட்டா கொடுக்குறோம். அதுல இருந்து ப்ராடக்ட் மாடல் இது. அதை ஜூம் அவுட் பண்ணுங்க அபிஷேக். Still complete diagram. Yes, amplitude level shifter. Then the final output have been given to the modulator. Modulated we required input message signal. Message signal have been given with a carrier signal FC of t. So modulator we have a message signal and then carrier signal. The final output will be differential phase shift keying is our expected final output. Okay. So we have completed the 4 transmitter diagram of BPSK, BFSK, QPSK, and DPSK. Okay, guys, each one. Okay, now you can go to the receiver diagram. So what we need to perform in the receiver?
So receiver modulator signal, sir.
Modulated input, exactly. Okay, so what is the transmitter output? Here we need to given as an input. So in receiver side also we need to give again carrier signal. Now you can verify. Okay, we have given x of t is our transmitted output that as an input. Here we need to give again the carrier signal psi 1 of t, right? கரெக்டா? ப்ரீவியஸ் டயக்ராமோட கம்பேர் பண்ணுங்க. அங்க நம்ம வந்து டிரான்ஸ்மிட்டர் டயக்ராம் எடுங்க பிபிஎஸ்கேக்கு. guys you can zoom out. So what is the carrier? அங்க நம்ம என்ன carrier யூஸ் பண்ணோம் டிரான்ஸ்மிட்டருக்கு? psi 1 of t. So in receiver side also we need to give the same carrier. Okay, hello.
Yes, sir.
Okay, then we need to perform integration பண்ணாலே எனக்கு integrationனாலே என்னது? We need to perform the whole process. Final value 0 to TB ல நான் வந்து integrate பண்றேன். integrate பண்ணிட்டு அந்த valuesல up to it mean a bit rate. TB refers the total bit rate or the time period for the bit to be transmitted. So what is the two condition decision device? If in case எனக்கு bit 1 இருந்ததுன்னா x1 is greater than 0. Okay, if in case bit is 0, எனக்கு பைனரினாலே இந்த possibilities தானே இருக்கு. We have either 0 or 1. If in case 0 இருந்ததுன்னா x1 value is less than 1. கரெக்டா இல்லையா? பைனரி சிக்னல் எப்படி நம்ம டிரா பண்ணுவோம்? ஃபைனலா 0 இருந்ததுன்னா there is no amplitude. If in case 1 இருந்ததுன்னா we will have some amplitude. கரெக்டா? Okay, now you can compare the next two diagrams, transmitter and receiver. BPSK we have completed. What is the next one? Binary. BPSK we have completed. What is the next diagram? Show the title. Abhishek. You can zoom out. So what is the next diagram? Compare the transmitter and receiver part. Abhishek, அது கம்ப்ளீட்டா வைங்க. கீழே பார் கட் ஆகுது.
Okay, sir.
You can zoom up பா. டைட்டில் இல்லாம உங்களுக்கு எப்படி புரியும்? They themselves zoom it. No issue. I need title with transmitter and receiver diagram. Yes. Yes, now you can zoom in coherent BFSK. Transmitter part la anga B binary FSK is our final output. That is our input here in the receiver part. There we have given psi 1 of t and psi 2 of t as a carrier. Here also we need to give the same carrier. Then we need to perform integration part. Integrate பண்ணா எனக்கு அந்த particular part மட்டும் கிடைக்கும். Then the positive part is the upper signals are a positive one, so plus. The negative signals, the lower signals are negative. So both have been combined. Finally, we know binary signals either we will have either 0 or 1. So based on the condition, if L is less than 0 mean 0, if L is greater than 0 mean 1. Okay, yes, now you can go to the next transmitter and receiver diagram, QPSK. Guys, இது புரியுதா? அண்டர்ஸ்டாண்ட் ஆகுதா? Guys, I need your response.
Yes, sir.
Again, the transmitter output have been given as an input, the same carrier. So what is the carrier we have given in the QPSK? What are the two carriers? Psi 1 of t, psi 2 of t. Here also we need to give the carrier. Then integration. For the common diagram na idhula endha difference me irukadu. Now you can compare the diagrams. Whether it is understandable, guys. Receiver நாலே நம்ம என்ன பெர்ஃபார்ம் பண்ணனும்? சேம் கேரியர் டிரான்ஸ்மிட்டர்ல நம்ம என்ன கேரியர் கொடுத்தோமோ அதே கேரியர் ரிசீவர்ல ஜெனரேட் பண்ணனும் along with the transmitter modulated output. Then we need to perform integration, then decision device. அவ்வளவுதான். எல்லாத்துலயுமே அதே தான் காமனா வரும். Then here also we have two psi 1 of t, psi 2 of t, then separate integration, then individual decision device 1 and 2. Both have been combined. Combine பண்ணாலே என்ன process? Multiplexer. Okay, then final output binary wave. Okay, what is the last diagram? Differential phase shift keying oda receiver enna anga namakku final output enna vandhudu DPSK signal that we are given as an input to the band pass filter. Okay, band pass filter ku na adha input ah kudukuren. adila irundhu na differential nale anga nama enna pannom transmitter la we have a given delay in the transmitter part. Here we need to reverse the delay. Guys, have you understand? In transmitter, what is the direction of delay? Okay, from output to input. Okay, here now you need to look at the direction of delay from input to the final output. Then modulator, we already know any input, any receiver input that we need to perform demodulation, then demodulation plus integration. Integration panna output we are given as a decision device, whether 0 mean L is less than 0, if in case 1 mean greater than 0. Guys, have you all understand these all the transmitter and the receiver diagram of 4 topics? BFSK, BPSK, QPSK and the DPSK. Guys, I need the response in the chat box. If in case any queries, post it now. Have you understand? I need the response from all 45.
Yes, sir.
Do the response in the chat box. Whether this comparison chart is useful?
Yes, sir.
Guys, everyone do the response in the chat box. I received only one so far. Karthik, Monica, Deepika, everyone do the response in the chat box. What are you all doing, man? Still. So receiver is a replication of, hello? Receiver is a reverse process of the transmitter part. Okay?
Yes, sir. Yes, sir.
Yes. Guys, any doubts you can post it now. Guys, if you have understand the 3, guys, just look it out. Meanwhile, we are preparing. Each one is individual part C type of question. Okay? You know the mark for part C, minimum of 15 marks. So parallelly, we are preparing almost 60 marks ku nama at a time la prepare pannit irukom. Okay, try to understand. Okay, any doubts you can ask me now. Okay, next one, signal space diagram. Yes, thank you, thanks for your response. Hope you have understood. Still I have received only 10. I don't know why. Megas, have you taken the attendance?
சார் அவனுக்கு நெட் ப்ராப்ளம் சொல்லிட்டு வெளில போயிட்டு ரீஜாயின் பண்றானா சார்? எடுத்துட்டான் சார், அவன் அட்டெண்டன்ஸ் எடுத்துட்டான்.
Okay. Is why only 43 pa? While joining around 53 I have seen. Why they are leaving without any information? I'm regularly watching it. This is not good. Yes. Okay. So hope you all understand all the transmitter and receiver diagram of 4 different digital modulation techniques. Okay. So what is the title of first one? Binary phase shift keying. So binary phase shift keying la how many message point ba? So what is the next title? Signal space diagram. Okay. Very simple. Simpler சொல்றேன் பாரு. Message point 1 அது binary phase shift ன்றதுனால நமக்கு binary னே வந்துருது. Binary நாலே நமக்கு என்ன 2 points தான். The first point is right hand side message point 1, left hand side message point 2. The positive amplitude is root of negative amplitude or negative energy is minus. டுவெல்த்ல படிச்சிருப்போம் கைஸ், ஞாபகம் இருக்கா? Region of convergence. Any response from your side?
Yes, sir.
Human la irukku sir.
Convergence, divergence, yes, sir.
அதேதான் curl, invergence, divergence. Okay, here we are finding the region. Okay, அது எந்த region வரைக்கும் எனக்கு signal வந்து transmit பண்ணும் அப்படின்றது அந்த கான்செப்ட். ஓகே, அதான் அந்த டைட்டிலே பார்த்தீங்கன்னா signal space diagram. Okay, here space refers our signals are sending in wireless. Okay, wireless mediumனாலே என்ன, ஏர் மீடியம் தான் நான் வந்து சூஸ் பண்றேன். ஏர் மீடியம்னு வரும்போது அது ஸ்பேஸ்க்கு ஈக்குவலானது வந்துடுது. ஓகே, அதனால தான் சிக்னல் ஸ்பேஸ் டயக்ராம். ஓகே, அந்த ரீஜியனை தான் நான் இங்க என்ன சொல்றேன், பாசிட்டிவ் ரீஜன் எல்லாமே Z1 ரீஜியன். ஓகே, நெகட்டிவ் ரீஜன் எல்லாமே Z2 ரீஜன். அவ்வளவுதான். ஓகேவா? Can we go to the next one?
Yes, sir.
Okay. Go to the next diagram, pa.
That's
Now
it,
you
sir.
can compare. Now you can compare the second diagram with the first one. இப்ப
Sir,
டைட்டில்
only
என்ன நம்மளோட?
region changes, sir.
Yes.
Region changes, sir.
Region changes. அதான் அந்த கன்வர்ஜன்ஸ் அந்த லொகேஷன் மட்டும் தான் வேரி ஆகும். ஓகே, பேஸ்ட்
sir.
ஆன் அவர் கேரியர் சிக்னல். இங்க பாத்தீங்கன்னா மெசேஜ் சிக்னல் பாசிட்டிவ் பார்ட்ல தான் இருக்கு. அதே செகண்ட் சிக்னல் பாத்தீங்கன்னா பாசிட்டிவ் ஒய் ஆக்சிஸ்ல இருக்கு. ஹேவ் யூ அண்டர்ஸ்டாண்ட்?
Yes, sir.
ஓகே, வேர் psi1, வாட் இஸ் psi1? நம்ம டிரான்ஸ்மிட்டர்ல psi1 நம்ம என்ன ரெஃபர் பண்ணிருக்கோம்? கேரியரா?
Yes, sir. Yes, sir.
ஓகே,
Phase.
கேரியர் சிக்னலோட மேக்னிடியூட் தான் ரூட் ஆஃப் இபி. ஹேவ் யூ அண்டர்ஸ்டாண்ட்?
Yes, sir.
ஓகே,
sir.
அதே இது psi2 ஓட மேக்னிடியூட் தான் ஸ்கொயர் ரூட் ஆஃப் இபி. ஓகே,
Yes, sir.
தட் இஸ் a கான்செப்ட். ஓகே, அந்த ரெண்டு ரீஜன்ல மட்டும்தான் எனக்கு வந்து எக்ஸைட் ஆயிருக்கு. ஆல் அதர் ரீஜன்ஸ் ஆர் Z1, Z2, Z3, Z4. ஓகே, இட் பாசஸ் த்ரூ த சென்டர் ஆஃப் த ஆக்சிஸ். அவ்வளவுதான் டயக்ராம். ஸோ வாட் இஸ் திஸ் டாபிக்? பைனரி ஃப்ரீக்வன்சி ஷிஃப்ட் கீயிங். கரெக்டா? கேன் வி கோ டு த நெக்ஸ்ட் டயக்ராம்?
Third.
Third one, what is the title? What is our title? Binary.
Sir,
Binary
What is our third?
quadrant.
QPSK. What is our third diagram?
Quadrant phase shift key.
Quadrature. Quadrature நாலே 1/4 ஆ?
Yes, sir.
Okay.
yes, sir.
Q refers 1/4. 1/4 நாலே எனக்கு எவ்வளவு ரீஜன்ல எனக்கு எக்ஸைட் ஆகும்? It need to cover all the
1/4.
4 regions. Correct? So now you can look at the outer line. The region 1, Z1, clockwise direction la paru. Z1 and Z1 is in clockwise direction. அதே மாதிரி Z2 ஓட டைரக்ஷன் பாத்தீங்கன்னா டுவர்ட்ஸ் லெஃப்ட் ஹேண்ட் சைடு. ஓகே, அதே இது அப்பர் லெஃப்ட் சைடு தான் Z3, அப்பர் ரைட் ஹேண்ட் சைடு தான் Z4. Z1, Z2, Z3, Z4. ஓகே, are you looking at? Hello.
Yes, sir.
ஓகே, இப்போ Z1 ஓட ரீஜன் தான் மெசேஜ் பாயிண்ட் 1 ஆ?
Yes, sir.
ஓகே, அதோட மேக்னிடியூட் நமக்கு தெரியுமா? வாட் இஸ் த கேரியர்? கேரியர்ல என்ன மேக்னிடியூட் போட்டுக்கோன்னு பாருங்க. ஸ்கொயர் ரூட் ஆஃப் E/2. QPSK ஓட டிரான்ஸ்மிட்டர் டயக்ராம் ஷோ பண்ண அபிஷேக். QPSK transmitter diagram. Let's show the QPSK transmitter diagram. What is the magnitude here? Carrier oda magnitude ennapa? Square root of. So what is the magnitude of psi1?
2 square root of 2/2.
Square root of 2/t. Correct?
Yes,
அதுதான் நம்ம இங்க magnitude எடுத்துப்போம் பாரு. Signal space diagram போங்க. Now go to the signal space diagram. Now you can zoom in and then see what is that magnitude? Square root of positive part எல்லாமே square root of E/t ல இருக்கா?
Sir, E/2, sir.
Okay, Z1 region Z1 refers message point 1, Z2 refers message point 2. Since it is left hand side, it is a negative side, so that's why minus square root of E/t. And then Z3 is a region number 3, message point 3. So what is it? Whether positive side or negative side? This is also in negative part. So what is message Z4 region? Message point number 4. That is in positive side. So that's why the magnitude is square root of E by 2.
Yes, sir.
Okay.
Yes, sir.
Now tell me what is the 0, 0 region? Which one? 0, 0, 0, 1, 1, 0, 1, 1. Now tell me what is 0, 0 region? Whether Z1 or Z2 or Z3, Z4. Debit in dibit. Dibit nal enna 2 bit. Okay. So which region is 0, 0? புரியுதா? Dibit
Yes, sir.
0. Which region is 0, 0? Is it 1 or is it 2?
Sir, Z1, sir.
அதுல மென்ஷன்
Is it
பண்ணிருக்காங்க
1?
பாரு. 0, 0. அங்க பாருங்க டயகிராம்
Z2.
பாருங்க நல்லா. Z2 is a
Z2,
region for 0, 0 is a region for Z2. What is 0, 1? Z3.
Z3, sir.
Okay. 0, 0, 0, 1. 1, 0. What is the region?
Sir,
Z1.
Z1.
Is it 1, 1, 1?
Sir, Z4.
அவ்வளவுதான். இந்த 4 பாயிண்ட்ஸ் நம்ம மேக்னிடியூட மென்ஷன் பண்ணிட்டு then 4 regions. This is the region for region of convergence. Okay. So what is the title? Quadrature phase shift keying. நீ டைட்டில் வச்சு நம்ம ஞாபகம் வச்சுக்கலாம் ஈஸியா. We will have 4 regions. 4 regionsனாலே நமக்கு என்ன வேணும்? 2 bit. So 2 bit in terms of 0, 0, 0, 1, 1, 0, 1, 1. Then the region have been distributed. Okay வா? DPSK க்கு டயகிராம் இருக்கா? சிக்னல் ஸ்பேஸ் டயகிராம். Abhishek, zoom out. Okay. We don't have. Guys, have you understand the signal space diagram? Binary phase shift keying just 2 bits pa. So positive magnitude, negative magnitude. Next one என்ன? Binary frequency shift keying 4 regions வரும். ஆனா நம்ம 2 regionல மட்டும் தான் magnitude நம்ம place பண்றோம் since both the values are positive.
Sir,
Okay.
differential வரையில sir.
DPSK க்கு diagram இல்ல. அது வந்து different-ஆ இருக்கும். It's not seems like this one, so that's why I haven't drawn. With the textbook I will show you. Okay. Okay. Quadrature phase shift key we will have 4 regions, so that's why 4 parts of diagrams. Okay pa, you can go to the next page pa. Abhishek.
Sir, next page.
Yes, these all
Sir. Hello, sir.
Hello?
Sir?
Yes, sir. I got a call, so that's why.
Oh, okay, sir.
Okay. So have you compared these four parameters? This is also easy. First one, S of t. What is S of t? Is our symbol, okay, or signal னு வச்சுக்கலாம் இங்க, ஓகேவா? our message signal தான் இங்க S of t ன்னு எடுத்திருக்கேன். ஸோ இங்க என்னோட மெசேஜ் சிக்னல் என்ன? S1 of t and S2 of t. ஸோ இதை நான் மேக்னிடியூட்ல எழுதும்போது root of EB, ஓகே, S21 refers minus root of EB, ஓகேவா? ஓகே, இந்த சேம் கேரியர் நாம என்ன யூஸ் பண்ணோம்? BPSK ஒரே ஒரு கேரியர் தானா? what is I1 of t? root of 2 by TB into cos of 2 pi FC. Okay, when both have been modulated, modulate பண்ணா என்ன வரும்? x1 of t is equal to modulation பண்ணோம், என்ன பண்ணோம்? Integration the product of message signal with carrier signal. கரெக்டா? x of t product with psi of t. Hello?
Yes, sir.
Okay, so what is the carrier frequency for BPSK? FC refers NC by TB. Okay, power spectral density என்ன? power spectral density ஓட representation N0. Okay, now we have completed coherent BPSK. Okay, phase shift keying. Now you can go to the coherent BFSK. What is the signal? Here I refers it will vary. Okay, incidence it mean instantaneous frequency. Carrier BFSK ஓட carrier என்ன? psi I of t. Here also FC of t. Okay, it varies with the time limit 0 to TB வரைக்கும் இது வந்து இதாகும். So here two inputs x1 of t and x2 of t. If you have looked at the transmitter diagram, so x1 of t modulate பண்ணா எனக்கு என்ன வேணும்? Message signal plus carrier signal. So S1 of t plus carrier signal. Then Fi refers instantaneous frequency is equal to NC plus I divided by TB. Here we have instantaneous constant. It means varying frequency. So that's why I varies from 1 to infinite. So what is the frequency component? Power spectral density for BFSK? N0 by 2. Okay. Now you can go to the next one. Coherent binary QPSK, quadrature phase shift keying. So quadrature phase shift keying refers, there also we have 4 quadrant. So generally we are writing the signal as SI of t. So quadrature refers 4. So that's why I varies from 1, 2, 3, 4. So how many signals we will have? S1 of t. What is the second one? Hello. I varies from 1 to 4. S1 of t. What is the second signal? What is the second message signal? Where I varies to 2. S2 of t. Where I varies to 3. S3 of t and S4 of t. 4 varying message signal. For that we have used 2 carriers, psi1 of t and psi2 of t, which varies between 0 to capital T. Both have been modulated. S of t, S1 of t plus carrier, X2 of t plus carrier. Okay. So what is the frequency component of QPSK? FC refers equal to NC divided by T. Carrying constant divided by T. Time period. Okay. So what is the spectral density for QPSK? The same value of previous one. BFSK order same power spectral density than N0 by 2. Okay. So what is the next one? Next comparison for differential phase shift keying. 2 message signal S1 of t, S2 of t. Abhishek, you can send the last part. It is not visible. Last one.
Oh, this side, sir. Okay, sir.
DPSK. Yes. So S1 of t, S2 of t are our message signals, where the time limit varies between 0 to 2 TB. So that's why we have written 2 different signals, 0 to TB as single signal and then TB to 2 TB as a different signal. So likewise S1 of t, S2 of t. Carrier signal is psi of t. We have used only one carrier, square root of 2 by TB into cos of 2 by f. Okay, this is the difference of 4 digital modulation techniques. So what are they? First one, BPSK, BFSK, QPSK, and DPSK. Okay, guys, try to understand. Each one is individual part B questions. Each one carries 13 marks. Okay, so the previous chart we have seen the transmitter diagram, receiver diagram, and signal space diagram, followed by the symbols, carrier, modulator output, frequencies, and spectral density. Okay, purely theoretical part. Any one of the topics surely coming in this unit 3. If you have understood this particular chart, okay, you can attend all those 4 questions without any issue. Yes? Hello? Hello?
Sir?
Guys, any questions?
No, sir.
Have you understand all those 4 topics and then subcategories, parameters? Okay. Then EB refers the total time period required for each. First one BPSK we required only one magnitude, so 1 EB. Second also we have we required only 1 magnitude EB. Third one QPSK we required 2 magnitude, so that's why twice energy. DPSK also we required twice than that of energy. Next one probability of error 1 by 2 into error function carry is equal to the magnitude EB divided by power spectral density. Then BPSK same value. The QPSK we have first part and then minus 1 by 4th of because of a quadrature. Okay. The DPSK 1 by 2 into expression of EB by M naught. Okay. Error function component. Then symbol duration TB. Okay. The last two QPSK and the DPSK we required twice than that of time duration. Okay. Minimum bandwidth we required for first one BPSK 2 into FB, and then for BFSK binary phase shift scheme we required 4 times of bandwidth, and then the last two QPSK and the DPSK we required one single bandwidth. It means a single shot of minimum bandwidth we required. Okay. Hope you have understood. Anyone you can stop the recording part.
Okay, sir.